want to just set the stage right for session today. See, this topic is very complex. Um, there is no right direction where I can lead you to and tell you, teach you exactly what your model would look like or how your output is going to look like. What we're going to do today, we're going to set the stage. I'm going to talk a little bit on what modeling is all about, how different models help organizations, why today organizations have to go behind data, and what all possibilities do they explore when it comes to collecting data and analyzing those data sets. So lot of text on the slides today. Pardon me for that. Uh, Two busy slides you will see. I'm not going to read through everything. I've put together those things so that you can read it later on and take that as a takeaway for you to build a little platform on this subject. So let me quickly share my screen and we'll start with our discussion. And I would really expect questions, because those questions will help me build my future programs. If the answer is not there today, I'll make sure that we include those topics titles in the upcoming sessions on the same subject. So we plan to do a lot of sessions on this subject itself, because this subject is very, very interesting, and this is something that all the organizations today would want to do. And as a business analyst, so I will focus more on the role as well, that how a business analyst should look at these modeling techniques. Pick one of the modeling techniques. I'll also share some tips and tricks as to how do you build a better model so that you are able to, what we quote unquote say, predict the future, learn from the history and predict the future. That is exactly what the intent of modeling is all about. Okay, now to start with, I would want to start with a lighter note. Now, forget about this word called Excel. Let's focus only on modeling. Okay, in the real true sense of modeling, not data, nothing. A dictionary meaning of what modeling is all about. Any thoughts? What comes to your mind when you hear this word called model or modeling? What comes to your mind? So do you see a picture of those beautiful ladies walking the ramp, those handsome men walking the ramp with all the outfits on them? So there is somebody at the back end who is asking them to wear those attires and walk the ramp and show it to the world, what they look like. Now, if you compare that model with all the attires, it doesn't happen just like that. It really doesn't happen. It is not that they pick some random clothings and they pick some random models and then they ask those random events, arrange a random events, and then they just walk the ramp. There is a lot of planning that happens at the back end. There is a lot of deliberation that happens. There is a lot of structuring that happens, where they pick up a theme, and then the designer would design their attires basis the theme that they pick, and then they move forward. And that is exactly what modeling is all about. Now, what we want to achieve with Excel modeling is to be able to predict the future. So these are few slide topics that I have, but lot much more discussion points that we will cover. Now, when it comes to modeling, just ignore this word Excel as of now while we are talking about the modeling part, because we're using Excel as an application to achieve the output. Otherwise, today There are a lot many more applications that people want to use, and they are using to create their own models. Now, Excel modeling, similarly like other modeling, is actually a process. It's a full process where you start with some underlying assumptions, assumptions in basis of the outcome that you desire. And then basis those outcomes, I will collect certain data, I will structure that data, and I will be able to predict. Okay, predict something basis whatever assumptions I've done. Now, when we apply Excel modeling, we use a lot of mathematical formulas. We use a lot of likelihoods of events occurring, uh, either some recorded events, or there would be some past events that have happened. So we collect those past events and then put everything together and try to forecast. Now, why forecasting is very, very important for today's organization success is because every organization needs to be profitable, and profits come from two places. One is increasing your revenues, and the second is reducing the cost that gets into generating those revenues. So the gross margin is actually comes out from revenue minus the cost. And that is something that we want to predict, that how would my organization look tomorrow based on what are we doing today. And that's where these different models come into play. Okay, so that's the underlying basis of what modeling is all about. Now, why we are talking about Excel? Because we're using Excel to create those models. Okay, now some uses of Excel models. So professionals in variety of industries, and it's everywhere now. It's not limited to any one industry or one type of a business, but today modeling or models are used across the length and breadth of the organizations. Now, lot of people use Excel modeling for project management, sales tracking, accounting. So accounting is one of the biggest consumer of Excel modeling. Okay, so accounting in terms of uh, how my future growth perspectives look like, how my future sales would look like, how my future product distribution may look like. Okay, and then how the financial modeling. So accounting and financial modelings are the biggest consumer of these techniques, because every organization is built on finances, right? Everybody wants to earn money, want to spend money. So Excel models are used at all these places and much more. So these are some top-notch things which I picked up, and I put them on these slides where people are using these models. Okay, so some more details on what project management, what sales tracking looks like, what are accounting models, and what are financial models. You can go through these slides. You can read through them later to have a little bit in-depth understanding on these four topics that we have listed. Now, what is included in an Excel model? What should be included? Now, there are several elements that would come into modeling. Now, it will start with an input. Every time there has to be an input. This input is going to be churned into an output. Okay. Now, in between input and output, there are few things that are required, and the key thing that would be required from an input to an output is the model requirement. Okay, so why is this model required, and what is this model going to do? And that is going to be based on what is the output that I need. And then to enable that, we will have some data tables. Now, this is an important term that we should know. data tables. Okay, so table is the key here. I can't use flat files. I can't use text files. My data that it goes into a model has to be in form of a table. So I'll also show you what that means and how do you convert any raw data into different tables, and you put some data labels around it. Okay, so data labels are also a key element while building your model, because when we want to use that data, we will call that data using the labels that we will give to the data set itself. So let's say you have the name of the people, you have their customer IDs, for example, or if you have a product table, so you have a product category, maybe a product ID, description of the product. So those things are data labels. So these are few basic things that will always be part of your model. Okay, so you need input variables, you need output variables, you need the model requirements. What are you building for? What are the outcomes that you require? What do you want to predict through these models? And then the structure of the model itself is in form of a data tables and data labels. Now, why Excel modeling is important? uh, Excel modeling is important because it is going to help all the businesses to do an accurate prediction about the future performance. Now, the key underlying word is future. I'm not talking about anything that happened or what is happening today. But the important key thing here is to understand that how my future is going to look like. So the models have to be so robust, error free, that those future performances or anything that I want to predict for the future is accurate. When we talk about accuracies, at least 80% and above accuracy is good enough for the data models. Okay, and here is an example where it says, a donut shop needs to accurately estimate that how many donuts they may sell in the upcoming months. Okay, if they know how many donuts, then they can plan that how much sugar, how much dough, and other things that they would require. So there is an expense, and there is also an output, which is in terms of the revenue. Okay, and the second part of this slide, it talks about the same thing but in a different way. The modeling will help organizations to make better decisions about the business. Okay, and that decision making is very important, because the decisions that you take and you implement, if those decisions are correct or not correct, can only be known when you see the outcome. So if I know the outcome today, then my decisions can be based on those outcomes, and I can have much better decision making. Again, the donut example comes here. So donut shop is better able to buy the right amount of supplies, since they can accurately predict the number of donuts they may sell the next month. Okay, so that is where the modeling really helps. And this is just an example. There are a lot many more things that the modeling is helping support today. And that will be a little bit clear on different types of models that are there. Now, this is not an exhaustive list of types of models. You can have any type of model, but these are some of the talked in town categories. So a lot of people talk about these 4 models. Within these 4 models, we may have many more models that you can create, plus your own models depending on what is the outcome that you require. So few types of models are like time series models. So based on historical time events, which is happening on time. Let's say there is a team sitting and doing outbound calls. Okay, so it's a time event. So you start a call and you end a call. So one time series happened, then the next call to the next call to next call, next call. So these are time series models. Now I'm able to make, say, 100 calls a day. And for making those 100 calls, I need 20 people. Okay, now I want to predict how would my how would my call volumes look the next month? So I will create some kind of a model using the historical data and be able to predict how many calls I will be able to do next month. And for doing those calls, how many people would I require today? Okay. Or even on the matrices, the time that I'm taking, the type of customers I'm managing, all of these can be modeled and can help you, predict the future. Now this was outbound, but then we also have incoming volumes. So almost 80 to 85% of the volumes that we receive are incoming, either calls or incoming transactions. And to do those transactions, we require certain skill set of people. We require certain number of people. Now for number of people, I would require a lot many more things. I would require hardware. I would require seating arrangements. If they're traveling, I would require cabs. So all of it, all these things, they're all cost things that are required to enable the business. And if I'm able to forecast that how my incoming volumes look like the next month, then everything else to support those number of people can also be forecasted. So if I'm expecting a million call next month, this month it was only maybe 80K, but next month I'm expecting a million call. I can plan ahead. If I need more people, if I need hiring, if I need more space, if I need more hardware equipment, if I would need more bandwidth, I should be able to, or I would be able to manage it by predicting. Okay, so those are certain examples on the time events. Then we also have econometric models. Okay, so mostly used by economists to predict the outcomes. Then there is something called as judgmental forecasting models. Okay, now judgmental forecasting models do not take a lot of data into consideration, but a lot of judgment from experienced people. A lot of judgments from experienced people are taken into account to predict what the future would look like. And then there's something called a Delphi method. So we'll look at what Delphi method. So Delphi method is also to do with some judgmental forecasting models. Let's look at each one of them because this is important. So we'll look at what time series models are. So I explained a little bit on the time series models. So this type of model uses historical data as the key to reliable forecasting, right? Historical data. So you will be able to visualize patterns. So you collect historical data, you visualize some data patterns, you get to know what different variables are there, like hours, weeks, months, or years, okay? Because this is on a time series scale. And then you can create your own forecast. Okay, so then econometric models are basically used by economists. So field of economy often uses econometric models to forecast the changes in supply, demands, pricing, taxations, collections. So those are very complex models basically. Okay, they use a lot of statistics into it, a lot of assumptions, and those assumptions are also close to reality because those predictions are very important. And then we have those judgmental forecasting models, where forecasting models of judgmental kind utilize subjective or intuitive information to make predictions. Okay, so mostly researchers would use judgmental forecasting. Then the Delphi method. So this method is commonly used to forecast trends based on information given by the panel of experts. Okay, so something like judgmental, forecasting models where the SMEs or the experts, okay, so they do some judgment. Similarly, in the Delphi model also, it is based on information that is given by a panel of experts. But then this is not at one level. So you have a panel that of experts whose opinions are counting. Then it moves to the next panel, and then finally you get the outcome from that group. Okay, so these are Delphi methods. And then the reality now hits the tarmac, where we now use artificial intelligence to create our own models. Okay, so we train the machine to collect the data, churn the data, and provide an output. And this is the future. Artificial intelligence is the future, where the algorithms are so robust, they are able to judge themselves, take decisions, and every robot, everything that goes into robots and robotics, it comes from artificial intelligence. Okay, so that's the future now. Each model has got a beauty in itself, and each model has got its own nuisance. That how do you do it, how do you achieve that? And it's very interesting to actually understand different kinds of models, because I've learned artificial intelligence, how to create those models, how to create those algorithms. So it is very, very interesting when you get the outcomes, and you're zapped, just zapped, that how the machine knew about it. I only trained the machine, but then machine gave me something, and you're zapped to see that how those machines are becoming more intelligent, with the intelligence that we built into it, and they are able to help us predict a lot of things. And we currently in EXL, we are using what we have now started saying, um, the automated operations. So we have also gone to an extent of doing the QA, the quality things, that nobody even thought can be done through machines. We are also reviewing the transaction. So if people are sitting and doing reviewing the transactions, then I cannot review 100% of all the transactions. So I will always drill it down to few transactions, and basis those few transactions, I would understand what the patterns look like. But today I'm able to audit 100% of the transactions that people are doing, and that too on a real-time basis. So the transaction is committed, and the bot starts, and it gets into the transaction, and it gives you a score, and a feedback comes flashing on your screen. This is where you made a mistake, so don't do it in the next transaction. So we started with backend transactions, but now we are also doing voice QA. We've also started doing voice. So the call is happening, and this algorithm is reviewing the call, and then also scoring the call. So that's where we have reached actually. Okay, and this is all because of the modeling. So the base is the same, the structure that you need to understand, that what this model will do, what are the inputs that would be required for this model to be successful, and then how do we refine this model, because this model will come across at least few of those transactions every day, which this model doesn't know. So this model has to train itself. So those are called auto ML models. So auto learning models. So it will record a new transaction, it will build back into its own algorithm, and start using that algorithm. So next time it runs through it. Okay, let's move a little bit more forward. What are some best practices while building your model? Okay. Now, again, I'm saying the best practices, if you go Google the space around, everybody using their own models, types of models, will give you best practices. So I picked few things from here and there. But other than what these best practices are, I am also going to talk about some practical best practices when we move to the practical part of it. Those are the key things that the business analysts need to keep in mind while you are creating your own models. Okay, so one key important thing while you're building your model is the consistency of your model itself. Your model should not be like bricks. One part of model picks one part of the data, the next part of your model picks some other part of the data, and then you're trying to marry them around. So there has to be a consistency in your model. So if you're building a model, you should know what. So planning is the key here before you build a model. Okay, and a robust planning, what we call, making a schema that how your model is going to look like. And the best tool I have found to start creating your models. Any guesses? The best tool for it? Any guesses? What should be the best tools to start building your model? Pratibha ma'am, Shalini ma'am, any guesses from your end? The best
Uh,
tools.
as a starter, I think Excel is the best one.
Okay. Shalini ma'am?
If we when it comes to programming, so I'll prefer Python.
Okay. Python. Wow. What Python is, I don't know. But the best tool I
Programming
found,
language. It's a programming.
I'm just kidding. But the best tool I have found is a paper and a pencil with an eraser.
Okay, you are saying first we need to do it manually. What
Ah,
we are like, if we have to design a model, what is your actual implementation on the paper? Then you can deploy with any software or any tool, whether it's Excel, Python, R, or anything. That totally
ab-
depends person to person. That's what you are
ab-
trying to say, right?
absolutely, absolutely. The best tool I've learned is a paper, a pencil, and an eraser.
Just like the whatever the thoughts in your mind, you should at least put that thoughts on the paper, and then you can
Absolutely.
portray in way where you want, what you want to depict, and what you want to show to the other people. Correct?
Absolutely. I'll give you with an example, Shalin ma'am, because you are champion in those languages,
No,
Python
no,
and
no,
other
no.
stuff.
I'm just learning. I'm exploring myself to
Okay.
get more better
So
things.
you start writing a code without thinking, or you
No,
will
no.
first think what is the output you require, right?
First I
Even
used
then,
to think like what data, what inputs I have, what approach I need to think to evaluate. So I cannot directly write code for any scenario. That is one of the best thing which you mentioned over there.
so is this slide make sense?
Yes, that is the only thing. Now, what input I have, as I'm living in a world where everything is data. So I need to figure out like what input I'm taking or what will be my output for that. And on that basis, in between, what are the steps, procedures I need to follow? What will be my approach to evaluate that performance? So that's one thing which I believe everyone should follow.
Okay, absolutely. So let's say you've written a code, you've written 1,000-line code in Python, and you run that code and it gives you an error. Is
So
it easy to go back into code and fix it? I'm not saying it cannot be done, but I'm saying it's not easy.
yeah, it's not easy obviously, because what the code I have written, I don't have the approach, like what is my main
Ah,
input, what is my output, and what problem business solution I'm trying to solve with that scenario. If I don't have that clarity, instead of writing 1,000 lines of code, 1,000 lines of code or 2,000 lines of code, it doesn't make any sense, because I'm not able to figure out what exactly my problem I'm trying to solve with the input which is I'm getting from the data which is available around us.
okay. But if you have the same thing on a piece of paper with a pencil, would you be able to figure out
Yes, obviously, because
and
I
quickly use an eraser, erase it and redraw it?
yeah, like if I have you have given me input and I have to classify or I have to predict time series for the sales of my own organization, but I have used some approach and I have seen like after 6 months the sales is only increased 6%. Obviously I'll
Ah,
go back and erase that point and check if I'll apply this strategy, it will be improvement or not.
absolutely. Thank you so much. I think that makes much more sense for all our learners today. This is coming sheer out of experience that we guys have, and every day we add more experience to it. Believe me, because this is still an
Yes.
area which is still expanding, and I don't know where that expansion would go. But then that is what it is. So your model has to be consistent. Okay, so that's one of the tips. Whenever you're creating a model, create a consistent model. So it should include using some formatting styles for your own models, having a consistent model, making it easy for others to add or remove information. So you're not the only one in the team who would be working. And please imagine that whenever we are doing these kinds of roles, okay, these kinds of jobs, you are not the only one. You will have team of people working alongside. Maybe the inputs are coming from different departments. You're collecting information. Now if nobody knows what inputs to provide, they will provide inputs the way they want to provide it, but that's not what we need. We would need the inputs to be given to us in a way that I will consume it. Okay, so that consistency in your model is very, very important. Then the transparency in the model. Okay, so the transparent model is one that is going to fit in one spreadsheet. Okay, difficult to imagine, but that is what the transparent model is. Because if you have created multiple sheets for your models, going between the sheets, you may just be lost in some of the sheets or spreadsheets. Okay, so it has to fit in one single spreadsheet. If multiple models are required, you plan it that way. You break your data sets in a way that one model feeds to the next model, and then next model feeds to the next model in case if that is required. And that is very common nowadays. One model cannot help. One model is going to give you an output which may not be a complete output that you desire. That has to go into the next model to the next model. So create smaller models that fits, that are clear, concise. It is easy to understand what is the purpose that this model is serving. And everybody should be able to make head and tail of that model. All right, so then next is the accuracy. This is the most important part in building your models, the accuracy. Your models have to be error free. You have to spend a lot of time in doing your own QA, or have a peer do the QA on your models. Because one error in your model is going to ruin the outcome, and you would not know what decisions taken from those outputs will lead the organizations to. So your model has to be accurate. So this will ensure that your model's accuracy is so you can make effective predictions. If an error message occurs, so we built within the models, we built few things where it is able to catch errors as well. And then we remove those errors or any information to avoid having a pair in your model. Okay. We also use to find inconsistencies. We can create filters. So what is inconsistency? I can give you an example so that you understand. So you have a field taking the names of the people. Okay. Now in between somewhere you have their IDs also built into the same field. Those are inconsistent model. Model will not understand, because you're training your model to pick the name, which is the text field, but in between you have a number. Okay, and the model will fail at that point. So model will not know what to do with this number now. So accuracy is the second or the top most priority for building your models. Learners, one of the key things that every model is desired to do is to give you an output in the minimum possible time. And let me explain you with an example. Okay, and that's where you will learn. So let's say I'm sure each one of you has at least a credit card or a debit card with you. Say yes or no.
Yes, Bharat, we do have.
Yes.
And you use that credit card on some POS at least once. Okay, now today we have those tap functions also available, right? The
Yes,
tap
with the Wi-Fi. Yes.
with the Wi-Fi. Okay, you call that Wi-Fi. Okay, fine. So you have that Wi-Fi feature. Now, how do the bank knows that it is the right person using the right card on the right POS? Just imagine this, okay? And then those Wi-Fi features also come with a restriction on the amount that you can transact using that one particular function. So earlier it was 2000 rupees per transaction. Now it has increased to 5000 rupees. But banks also give you an opportunity to set your own limits. So maybe 1,000, 500, whatever that limit is. Now you tap on that machine and imagine if there is somebody sitting at the back end looking at your transaction and saying, okay, approve or not approve. How would you feel? How would your experience go like? So the model that I need to build at the back end has to do this in a flash. And there is a huge algorithm behind, these kinds of transactions. They're not simple algorithms where you tap a card, it comes to the system via some, Wi-Fi routes, because those machines today are also Wi-Fi enabled. They are not like connected through wires. They're also in a virtual way. So you tap a card, there is, an information picked up by the machine, sent to the server goes to your bank authenticates, it sends out a message, and zip, it says, okay, approve or declined. So the speed of your model is the key for the success of a model. Okay. So modeling, whenever you're creating models, you may create a lot of complicated models, but the model itself should run in a Ziffy. But let's do one thing. Let's quickly move on to the practical part of it. Let me quickly share my screen. So I've done some outputs. Maybe I'll tell you, how did we do it. Uh, but let me give you a background of what this data is all about. Imagine this is not there as of now. So this is the data that I'm collecting on number of transactions that I receive every single day. Okay, so this is an input that I receive. Now, number one, the accuracy of this input is also important. Okay, so I'll link back to the slides a little bit, but now with the practical thing, right? So the input has to be consistent. Now let's say I'm collecting the number of transactions that I'm receiving, and all of a sudden, I have an entry like this. So this is going to interfere in your model. Okay, so your data has to be consistent. Your data has to be accurate for getting you the accurate outputs. That is what we meant, when we were talking on that slide. So now these are the transactions for almost 100 days starting from 1st January. Okay, so 100 days of data or on all incoming transactions. Now I want to predict how the future would look like, maybe a month down the line or 2 months down the line, something of that sort. Now what I'm trying to just tell you, the simplest model that anybody can create, the simplest one, okay, that's called moving average. And we used to use this. Okay, so these are some models that we have used in history. Those were the times when these models were the models that were available for us to do some predictions with the knowledge that we had. Okay, what is the moving average? It's an average of 2 data points or 3 data points, so depending on how much I want to average. So I'll do an average of previous 2 data points to predict my next data point. Okay, so I predicted average, and I said that either on 3rd of January I might receive 24 transactions, and then similarly the next day, so I might receive 28.5 transactions, and similarly I can simply copy this and put it here. Okay, so I am expecting these many transactions. So these were the simple models that were created. Now that was not all. What next after you've done this? You find the accuracy of your model. Now what is the accuracy? So this is predicted and this is actual, right? So you predicted 24, but you received 29. So what is the delta? Is -5. It could be +5 and then others would become minus. So you can decide what subtracts from what. But ultimately, I'm going to use an absolute value to calculate the accuracy of my model. Okay, so I'll do absolute. I think this last one. Okay, fine. Wow. Okay, so there is a gap of 5, 3.57. Here the gap is more. So we'll find the accuracy. So how accurate my predictions are going. And then rebatch this accuracy into my prediction model. So I said that on an average, I am off by around 8.22. Okay, so which means that if I predict that I am going to get 20 transactions, I may get either 8.22 less transactions or 8.22 more transactions. That's my accuracy today of my model. Okay, and I will use this and I will bake into my model and start to re-predict for more future things to happen. Now this was done manually and this was done exactly the way I'm doing for you right now. Okay. But now Excel has got more powerful things for you to define your models even more accurately. Okay, and that is done like this output. I'm just going to recreate this output for you. How did we do it? How did we get these modeling predictions? So under the data tab, we have this forecast slice, and one of the options in the forecast is to create a forecast sheet. Okay, so I want to forecast. So by default, it has picked up a lot of things, but I don't need all these things. Be 1 second, because I did it earlier, so it is just picking up. So I've selected this data. So it says where to start your forecast. Now your forecast would start from the last date available in this. 1 second, let me just cross this. So your forecast would start from the last date on your transaction. Everything else the model is going to use to build that forecast. Okay. So what is the forecast start? So from 410, where do you want the forecast to end? So you can decide. You cannot go endlessly. There will always be a last date that you can select. So depending on this data set, this model can predict up to July 19, 2022. Okay, not beyond that. So each model will have its own end date till what it can predict. So let's say I pick the last date that is available. Then confidence interval, I'll talk a little bit on this, what confidence interval is all about, and why it is important for us to know, because we're still doing a forecast. So confidence interval at 90%, that means my model accuracy, or the outcome of the model can deviate by 5%. 95% it will be accurate, but it will still deviate by 5%. Now what that 5% translate into, we'll just see. So since I have already selected the data, it has automatically picked, so A1 is my timeline range, and this is a value. And there are other things, but then let's not look at them, but let's just look at what this is going to generate. Okay. I've picked up the line graph. You could also pick up the bar graph, whatever you want to. First, let me pick the line graph. Let also do this, include forecast statistics. Okay, so this blue data that you see is your current data. This orange data that you see is the forecasted data, and the two lines above and below, okay, are your confidence interval. This confidence interval, the lower confidence interval and the upper confidence interval. I'll click on create. Now it has created two things for me. Let me pull it to one side. Okay, we'll look at this a little later. Let's look at the data sheet that it has created. Now, one thing, if you imagine that whenever you're using models, the models will also always be linked through a data table. Now, what I have done here is not a table, actually, okay? It looks like a table, but this is not actually a table. These are called flat files. These are certain values written in certain cells. But whenever there is a model that you create, this will always be linked to a table. Okay, and how do you know this is a table? People who keep using Excel, one, the table will always have a banded rows. They will have a structure like this, and this table will also have a name. If you look at the table properties, okay, one second. Where did the table properties go? Okay, one second. I'll just find out where. So this table can be referred. This table will always have a name. Okay, that goes in the design part. Okay, fine. We'll come there, but let's look at what this is. So this is my data that was already there. Okay, till here. Okay, so this data was already there. It started this prediction from here. So basis the historical data, it says that your transaction on 11th of April, you can expect 41.34. Maybe let's round it off to the zero because this is doing number of transactions. So 11th, it says you can get 41 transactions with a minimum of 24.28 to a maximum of 58.4. This is the confidence interval. Okay. The next day, 35 with a confidence interval lower side 18.15 to 52.27 on the higher side. Let's put these also into clear calls. Okay. Now, so it has given me a prediction, and this prediction is entirely based on the historical data that I've given to this model, okay, which is these data sets. Okay, so now I can plan. Okay, I can plan that how many people would I require on 11th April, keeping in mind that I might get 41, but there is also a chance of getting 58. Okay, so I should have that in mind, that what if I get 58 transactions, how am I going to handle those? So I can plan much in advance. Now, when I reach this date, I will get my real number as well, right? So let's say I got 45. I will loop that back into my model. Okay, so maybe I'll collect another 1 week of data vis-a-vis my predicted or the forecast, and I will rerun my model. And that's where, the accuracy of my model will keep improving day by day. Okay, has anybody heard about Carl Gauss?
Yes.
Carl Gauss? Somebody said yes. Oh, I like it. Carl Gauss, what did he do? What did Carl Gauss do?
A mathematician, he is.
Oh, very good. Yes. He was a scientist, mathematician, astronaut, a lot of things. Okay, very good. Now, Carl Gauss studied certain data sets and behavior of the data sets for natural or man-made processes. And what he discovered, that these data sets have got a pattern, okay, and that is what he termed as shape of the data. Okay, so he said that every data that you generate has got certain patterns, but every man-made or a natural process will have a certain pattern. And what is the pattern he said that these data sets should have? And my friend Arpit used a term called bell-shaped. Bell-shape. Now, what is a bell-shaped data? A bell-shaped data will look like this. Okay, with maximum number of data points here. And this is what Carl Gauss studies revealed. Okay, maximum data points will be here. And he said that this is the middle point of your data set. And there are 3 measures that we have for the middle points. Technically, we call them central tendency: mean, median, and mode. And it says all these 3 central tendency points will coincide here for a data which is this, normally distributed. Okay. Now that's the first point it says. The second point it said that if your data is normally distributed or it is bell-shaped, then this central tendency point, which is either mean, median, or mode, because all the three will be equal to each other, will divide your entire data set into two equal halves, with 50% of your data on one side and 50% of your data on the other side. Okay, which means this side will have 50% of the data and this side will also have 50% of the data. Then he says that no process on this, in this universe, okay, wherever it can go, wherever, whatever you know about the universe, can exist without variation. Okay, no data set will appear without variation. So if there is a process running, then the first instance of the transaction of the process to the next instance of the process of the transaction cannot be same. You try whatever, it will never, ever, ever, ever be same. Okay, so there would be something which is different. Okay, so there will be a variation, and the measure of variation is done through standard deviation. In short form, we call it SD, standard deviation. Okay. Now, standard deviation in layman's term is how far my transaction went from a certain data value. Okay. Or in this case, you can say how far the transactions have gone from the central tendency point, either mean, median, or mode. How far you've gone this side and how far you've gone this side. Okay. And one of the things that he discovered is that there is number of data points that he observed between some standard deviations. I'm not going too much in depth, but I'm saying, he said that if you go 3 standard deviations on the left and 3 standard deviations on the right, that's a variation, right? So you will always, you know, the process, it will always go, they will always move. You can't have a process like this. If this is like this, then it is dead. So your process will always be, should be like this. Your data point should always be like this. Okay, it cannot be like this. So he says that if you go 3 standard deviations on the left and 3 standard deviations on the right, you will have 99.73% of your data between these 3 standard deviations on the left or the right. Okay, which is almost, you know, if you round it up, it rounds up to 100%. Now, what is important, what we are learning to understand when it comes to data models, that if my data is normally distributed, then I know that all my data set will always lie between plus minus 3 standard deviations from the mean, because I'm not challenging what Carl Gauss studied and he gave us as the, either the normality theorem or normally distributed data. I'm not challenging that. I'm saying, okay, Carl Gauss, you said if your data is normally distributed, it will have a bell shape. It will always have 50% of data on the left and right of your central tendency points, and almost 99.73% of the data points will lie between plus minus 3 standard deviations. Now, what does this helps us to apply in the model is the prediction part, because that is what we are predicting, right? This helps your predictability of your data much more accurate if your data is normally distributed. Okay, so that is why we also need to learn, understand that if my data is normally distributed or not. So I need to know, understand the shape of my data to be able to predict better. If it is not, I'm not saying you can't model your data, but your data modeling accuracy cannot be predicted. So let's say you have a process like this. Okay, you have a process like this. Now, sometimes there are a lot of data points. So far, there are a lot of data points, so less from the central point. I don't know where the next data will go. Okay, because this is not normally distributed. I don't know. I can't predict. But here, I know that the next data point, whatever I add, if it is normally distributed, is going to lie between this plus minus 3 standard deviation, somewhere in between. So that means that when I have to model a data like this, I should also know what is the shape of my data. Correct? So I should know if my data is normally distributed or not normally distributed. Okay, I know for sure for this data set, this is not normally distributed because I just created some random data set. And hence my forecasting model is not going to be accurate. Now, in order to look at the shapes, one of the best ways to look at the shape is to draw an histogram. I'll draw it again for you guys and see the distribution. Okay, so how do I do a histogram? I select this data. I go to insert. There are other ways also. I will come to that part and I'll go to all charts and I'll select histogram. Okay, so you get a histogram. So histogram gives you a fair understanding of the shape of your data. Okay, so this doesn't look like a bell shape. This says that between 20 to 26.7, I've got the maximum number of data sets. Okay, see, this is the shape. So maximum number is here and minimum is here. So basically this says that, you know, this is for sure not normally distributed. Okay, this is not normally distributed. And the shape looks something like a flat distribution. Okay, so it has no shape. Just give me a minute. I'm going to use my statistical software to generate a normally distributed data. Just for your learning perspective. See the shape now? See the shape? So this is the shape of your data. So this data is normally distributed, and hence doing predictions on a normally distributed data is much easier, because I know that Mr. Carl Gauss said that my normally distributed data will always lie between plus minus 3 standard deviations. Okay, this can also help you know your outliers, or do your outlier management of your data. And that, what is outlier management? Because those are the data points that may hinder in your model. So those outlier data points needs to be removed to improve the accuracy of your model. Now, why do we remove them? Because those outliers would have come because of something that might have happened in the process input. Okay. Now, let me also explain you with another example. Arpit, can you unmute yourself for a minute? This is going to be interesting. And I think in the last class also, I took the same example where I said that, okay, Arpit is not able to unmute. Anyway, okay, so let's say, my marketplace where I usually go and buy vegetables is 15 minutes walking distance from my home. And every day I walk and come back. Now, how much time do you think I will take to walk and back from the marketplace? Sorry, say that
requirement. 30 to 60 minutes, depend upon requirements.
No, I'm not saying how much how much time I spend in my shopping, but I'm saying just going and coming back. If I add these two timings, how much time do you think I should take?
30 minutes max.
Absolutely. And my wife knows about it, that I'm going to take 30 minutes. Okay. And then, shopping, I may take another 15, 20, or let's say at the extreme 30 minutes, which means when I go out of my house and by the time I reach back, it is going to be 1.5 hours or maybe 1 hour. Okay. 15 minutes and 15, 30 and 30 minutes shopping. So 1 hour. Now, do you think that every day I'm going to take 1 hour? Exactly 1 hour. So if I start from my home at 9 o'clock, I will come back by 10. Do you think?
For every day.
Every day. That's not possible, correct?
Yeah.
Every single day, exact 1 hour, that's not possible. That is called variation. Sometimes I may take 1 hour, 5 minutes. Sometimes I may take only 55 minutes. Sometimes I may come back only in 40 minutes because I didn't find what I wanted. So, my shopping took little less time. Or sometimes I may take little over 1 hour because, I had to buy more stuff. But one fine day, I took 2 hours to return. Do you think my wife is going to question me?
Sure, absolutely sure.
These are called outliers. These are called outliers. Now, these outliers might have come because of something that happened on my way. I found my good old pal and I started, chit-chatting with this person. So I spent 1 hour only chatting with this person. Now, these outliers will actually reduce the accuracy of my model. And hence, these data points have to be removed. And when you remove these kinds of data points, your data starts becoming normal and it starts getting into this shape where your predictability of your model becomes easy. Okay. So similarly for this data also, I know this is not normally distributed. So either I will start managing the outliers, extreme values, okay, both sides. And this is both sides. And one fine day, if I come back in 20 minutes, again, I will be questioned. What happened? Oh, no, I forgot my wallet. I just returned from halfway. That's again, a special reason for that process to behave in a very shorter period of time. So both extreme values need to be removed. Anything which is outside of that 99.73% of the data needs to be removed. Then only your data becomes normal, and hence your prediction will be more accurate. So let's predict few things from this normally distributed data and see if my prediction is more accurate or not. Okay, now imagine this is the time that I've taken to process a transaction. You see these intervals now? See these intervals and see these, predicted numbers now. Observe these intervals here. Observe these intervals here. 41, 24 to 58. Such a huge gap. 18 to 52. 14 to 48. 22 to 56. And now observe these intervals. 17.65 to 22. 17.1 to 21. 17 to 22. Okay. And look at these forecasted numbers. Okay. So if I take an average, this is 20.13. If I take an average, 19.37, very, very close. That's where your model accuracy is going to improve if you have a normally distributed data set with you. Okay. There's a lot more on how do you make data sets normal and all. Maybe we can pick that up as a separate session in some upcoming classes. I know we have a class on statistics in the next month. Maybe I'll pick few topics on normality. If the data is not normal, what do you do? How do you make it normal and all of it? Then outlier management, all of it, I'll cover in those sessions. But so far, is this making any sense for you guys? I know we're left with little time right now, but there are two things I still want to cover before we end the session today. But I want to hear from you. In case you can't talk, you can put that in the chat. Okay, let me take a feedback from Shalini ma'am and Pratibha ma'am. Ma'am, is it making sense?
Yeah, it's really nice and helpful as well.
Arpit says it is very helpful in the chat box.
Okay, thanks Arpit. Okay, so I want to, so this was the easiest one, which is available as a data model because this is just based on a time series. Other than that, we also generate these kinds of statistics, descriptive statistics to see how my data looks like. Mean, median, mode, what is the kind of standard deviation, and then what is the variance, what is the shape, so kurtosis and skewness is one key things that we look at that helps us determine the shape. What is the range? It is too huge, 30, minimum is 20, maximum is 50. So this is also too huge to be a normally distributed data. Okay, and the confidence interval is 1.77. This is too huge. Let's generate same statistics for this data set. See how it looks like. So you select, I may select or may not select, it doesn't matter. So I go to data, I go to data analysis, and I go to descriptive statistics. So my input range is this. Do I have labels in the first row? Yes, I do. My output, let's put the output here. Give me the summary statistics. Okay, give me the confidence level of 95% mean as well. And then I do okay. So I got my data set. So now here the mean, standard, error, median, mode is not there. There is no repeating value, hence it cannot calculate standard deviation. Now observe the standard deviation itself. Okay, so here the standard deviation is 8.91, and here the standard deviation is 1.14. So the moment you start reducing the variation in your data starts becoming normally distributed. Okay, skewness, kurtosis, range, minimum to maximum is also not huge, and confidence interval has reduced to 0.226. Here it is 1.77, so it has got a huge interval. Here the interval is too small. Okay, and these are some indications that your data is normally distributed, but there are more indications, there are more statistical way to find out. Maybe we'll pick it up in another session, just for the limitation of time. So these statistics really help, and then probably I could also draw what I call box and whiskers plot to see the distribution itself. Wow. 1 minute, let me just change minimum 15 to maximum 25. Yeah, now it will show a better distribution. So this is such an amazing distribution. Okay, with mean here, almost similar kind of data, 50% data here, 50% data here, and then no outliers, well shaped data. Okay, so these are few statistical tools that will really come help to determine the shape, though it has also done the shape for me. So I think I'll pick one more. I can pick just one more topic. By the way, all these data sets are with you as well. This was in the package available to be downloaded. So you have this presentation as well, all these data files available for you to practice. Okay, so this is one example, a data set where you have some data that is being collected, but this is not in one single set. So I've got some student details here where we have the student ID, student first name, last name, date of birth. Okay, what is the current age, gender, address with city, state, and zip. And then there is another tab where you have which classes are they attending with their class code or the class number and the class name. Then we also have what are the grades that these people are getting in each of the semester. Okay, so student ID, class ID, semester, grade. Then we have some data on semesters. So this 17 semester, fall 14 winter. What is the start date on each semester? And I want to model this data to see how my students' performance um, is, how my student performance is going. Now I cannot analyze this data the way the data itself is. I will have to put that into a model, and before I put anything into a model, I need to convert these flat data files into what I call tables. And how do we convert the data into tables? It's very easy. You select the data that looks like something that you see on flat files. All you need to do is say control, press the control key, and T, the letter T as in table from your keyboard. You will get this pop up. And then where is the data for your table? So I've already selected. Does your data table has a header? Yes. All you need to do is just see if this is checked and your entire data set is selected, and you click OK. So the moment you click OK, see this has been converted into a table, and the name of your table appears right here in the design tab, this table 1. I will rename this table 1 to students detail. Okay. Okay, it doesn't allow spaces. student underscore details. Okay, so that's the name of my table now, student details. Similarly for classes, I will select this entire data, control T. My table has headers. Yes, I'll say okay. This table 2, I'll rename it to classes. Then I got the grades. I'll convert this into tables. While I'm doing so, my friends, the basics will still remain the same. I've already collected this data. I've created this structure. But even before I would have done that, I would have sat with my team. I would have done a lot of discussions on what is it that I require, what are the inputs that would be required, how would I structure those inputs, are those inputs available at one place or not? If not, that then how can I get them into one place? That activity is already done. Okay, so this 4 tables now I have. Now I want to use these tables for my analysis. How do I push it forward? And to do that, I use something called a power pivot. Okay. So power pivot, I can create power pivots. If I already have a power pivot, which means that I already have a lot of data into it, I'll go to manage. If I want to add these tables to data model, I will do that. Okay. So I still do not have any data model that I know. So I'll start creating data models now. So you click and say add data model. So see what it is now doing. It has picked this first sheet, the table, and created a linked data source, which is student details. I'll go back and I'll say add to data model. Okay, so I've got classes right now, then grades, and then finally semesters. Okay, so I've got everything here into my Power Pivot. Now, if I create a pivot table now, let's do it on the existing worksheet, or let's do it in new worksheet. Now I have an opportunity to pick from any of these tables and create one pivot from all these, depending on what I need. So let's say student ID, put it in the row, then maybe the semesters and maybe the grades. Okay, sorry, we missed one thing. We created relationships. Okay. Anyway, a lot more time we need to spend to be able to do this. But I just wanted to give you a flavor of how you start modeling your data, and then start creating outputs from these data models. And the only place in Excel is Power Pivots, which helps you with a lot of things. So on this last slide, I've also got a hyperlink for you. Okay, or it's a link. This is from the Microsoft website itself. It's an amazing material, or you can say a complete tutorial on data modeling. Okay, so that's the link that will take you to this Microsoft website support page. It's a complete tutorials on data modeling. How do you start? How do you export? So it talks a lot in depth. So these are the 6 multiple links that are available that will take you to a lot of things on data modeling, Power Pivots, help, and all of it. While we prepare for the next session, maybe this is going to be a good read for you guys in case you want to do more in depth onto data models and stuff like that. I want to leave you with this thought as of now.